Alright, it's Niaki Osteozone. So today we are still going on with the chemistry series for the O levels, right? So in the previous session we did the atoms, the elements, and the compounds, and we managed to define the term atom, to define the term element, and also to define the term compounds, lastly to define the term molecule. So today we are going to continue with this topic, right? Making sure that each and every objective is being dissected during this session, right? So that you can fully understand, you can fully have the picture, right? So we discussed about the nuclear notation, right? And then we introduced ions. We introduced the ions yesterday. We also have the introduction of the periodic table, what we call periodicity. So we introduced the periodicity again. So today we are going to just have a flashback and then proceed with our discussion, right? So in atom, we said it is the basic unit of matter. It is the simplest unit of matter, right? So atoms can be broken down into what we call the subatomic particles. And then these are the protons, and then these are the neutrons, and then these are the electrons. So these three are what we call the subatomic particles. And then we have the subatomic table with the particle here, and then we are having protons, electrons, and then neutrons, location, and then the charge, and then the mass. So the protons are located in the nucleus, the electrons in the shells or in the orbitals, and then the neutrons in the nucleus. And then the charge, so the charge for the protons is +1, and then that one of electrons -1, and then the neutrons, it doesn't have any charge. And then the mass for the protons 1 unit, electrons 1/1840, and then neutrons 1 unit. So this is the table you need to know by heart, right? So we are going to highlight what we call the deflection. So we have the deflection of these subatomic particles in the electric field, and also deflection in the magnetic field. So deflection is based on the charge. So these charges are what governs the deflection of the particles, right? So let us say we are having this electric field, this positive terminal here, and then this negative terminal, and then we are having a beam here, right? So the beam contains the subatomic particles. They are still intact here before this region of the electric field, right? So here we are having the protons, the neutrons, and the electrons here. But when they pass through this electric field, they are going to be deflected, right? So deflected is governed by the charges and the masses, right? So the charge and the mass are what governs the deflection. So electrons are negatively charged, as you can see. So they are unlike charges. Let me highlight that. Unlike charges attract, right? And then like charges repel, right? So electrons are negatively charged, so they are going to be attracted to this terminal, the positive terminal, and then they are going to be repelled from this negative terminal, since like charges repel. So we are going to have electrons attracted to this positive terminal, right? So this is the deflection. These are the electrons, and then you indicate the negative sign, right? And then we are going to have protons. Protons are positively charged, so they are going to be attracted to this negative terminal and then repelled from this positive terminal. So we are going to have protons here, right? I want you also to take note on this angle, right? So electrons are being deflected first, as you can see, right? We are starting with electrons. Why? Because they are lighter. That's why they are being deflected first. So electrons are being deflected first. Why? Because they are lighter. They are easily deflected because they are lighter. And then protons are deflected lastly. Why? Because they are heavier compared to relative to the electrons. And then the neutrons, they are not deflected. Why? Because they doesn't have any charge. They are neither attracted to the positive nor to the negative terminal, right? So this is the deflection in the electric field. Take note of is that electrons are being deflected first, and to explain why, because they are lighter, and then they are deflected to the positive terminal. Why? Because they are unlike charges attract, and then like charges repel. So this is the deflection in the electric field. So we have another deflection in the magnetic field. So let us say this one is the magnetic field, and then we are having another beam, and then the neutrons, they remain undeflected. So we are going to deflect the protons in the electrons in the negative, in the opposite sides. So if we are to deflect the protons here, it simply means to say we are going to deflect the electrons on the other side. But we must take note on that electrons are deflected first. Why? Because they are light. So these are the protons, and then these are the electrons. So this is the deflection in the magnetic field. As simple as that. So you need to understand this, and you mustn't cram this. You're simply applying the mass and the charges. As simple as that. And then for the location, they contribute to mass. So protons and neutrons together, they make what you call the nucleon number, which is the mass number, right? Are we together, guys? So this is what you need to know. And electrons doesn't contribute to the mass of an atom. Why? Because they've got a negligible mass of 1/1840. So this is what you need to know. This is what you need to understand concerning the subatomic particles, right? So we are now proceeding to what we call the John-Dalton's postulations. The John-Dalton's postulations of 1803, right? So these are what governs the chemical reactions, the compounds, and the atomic structures, right? So you must understand these facts, and you mustn't claim them. You must have the understanding of these facts, right? So what are we saying? So the first statement says matter is made up of smallest particle called atoms, right? And then we go on to the second one, which says all atoms of the same element, they have the same chemical properties. All atoms of the same element, they have the same chemical properties. All atoms of the same element, they have the same chemical property or characteristics, right? And then we go on to the next one, which says different atoms combine in small numbers to form compounds. So we explained in the previous discussion what is meant by the term compounds, molecules, elements, and atoms, right? So different atoms, they combine in small numbers to form compounds, right? And then we go on to the last one, which says during a chemical reaction in which new compounds are formed, atoms are neither created nor destroyed, but they are merely rearranged. During a chemical reaction when new compounds are being formed, atoms are neither created nor destroyed, but they are merely rearranged. So you're going to need this one when we are doing the balancing of equations, the chemical reaction. We are going to need this fact. So we are saying during a chemical reaction in which new compounds are formed, atoms are neither created nor destroyed, but they are merely rearranged. They are merely rearranged. So you must know this one by heart. You must know these facts by heart. John Dalton's postulations, right? So during a chemical reaction in which new compounds are formed, atoms are neither created nor destroyed, but they are merely rearranged. So I'm going to introduce what we call the chemical characteristics. So chemical characteristics are governed by what we call the electronic configuration, and I believe in the previous session we did the electronic configuration, right? So electronic configuration, the first shell is filled with 2 electrons to have what we call the doublet state, and all the other shells are filled with 8 electrons to have what we call the octet configuration. So the reason or the agenda behind all these chemical reactions is to achieve what we call stability. So stability is found in which group? In group 8. So we said we have what you call the valence number. The valence number, the number of electrons in the outermost shell. So all the elements, they want to have number of electrons in the outer shell. So the valence shell is the outer shell, right? Valence shell is the outer shell. And we also have the valence number, which is the combining power, right? So during a chemical reactions, atoms want to have 8 electrons in the outermost shell. They want to have 8 electrons in the outermost shell. So this is the electronic configuration of a noble gas, the group 8 elements. So group 8 elements are also called noble gases, right? So they want to have electronic configuration like that one of a noble gas. So they will react either by losing or by gaining or by sharing electrons, so that they will have 8 electrons in the outermost shell. Are we together, guys? So in the previous session, we did the formation of the cations and the formation of the anions, right? So we said cations, they are formed by the metals, and then anions, they are formed by the non-metals. So we said that these are the positively charged ions, right? Positively charged ions, and then this one negatively charged ions, right? So we said all the metals, they react by losing electrons. All the metals react by losing electrons, and then all the non-metals react by gaining electrons. Are we together, guys? So the metals, they are going to so let us say, for example, is our periodic table. So this is the periodic table, right? So we are going to have lithium first. So let us say lithium 37, right? So this one is the mass number, this one is the proton number, right? So the first shell is filled with 2 electrons, and then we are left with 1. This one is the 1. So we said the number in the outermost shell, this number is what you call the group number. The number of electrons in the outermost shell denotes the group number, and then the number of shells denotes what you call the period number. So let me highlight that one. The number of electrons in the outer shell denotes the group number, right? And then the number of shells denotes the period number. So the number of shells, this one is the first shell, this one is the second shell. So we are having 2 shells, meaning to say this one is in period 2. So the number of shells is equal to the period number, and then the number of electrons in the outermost shell is equal to the group number, right? So this one is the period 2, this one period 3, 4, 5, etc., right? So you should take note on that one. Are we together? So we are saying that lithium, all the metals, they react by losing electrons. So lithium is going to lose this 1 electron to achieve stability, so that it can have 2 electrons in the outermost shell, since they want to have the same electronic configuration like that one of a noble gas. All the elements, all the atoms wants to have the same electronic configuration like that one of a noble gas. So they will react either by losing or by gaining or by sharing electrons, so that they will attain the stable noble gas electronic configuration. Are we together, guys? So lithium is going to lose this 1 electron to have 2, which is the noble gas helium. So helium is the duplet, is got a duplet electronic configuration, having 2 electrons in the outermost shell, right? So lithium is going to have the electronic configuration which is same as that one of helium, right? So the lithium ion is 1+. So at times will be examined so we did this in the previous session, right? So this one is just a flashback, so that you can have the understanding of what we are going to discuss here, right? So we are going to use, for example, sodium, right? So sodium is Na23, right? So for a neutral atom, for all the atoms on the periodic table, the number of protons is equal to the number of electrons. But for ions, the number of protons is not equal to the number of electrons for ions. right? And then this one is for atoms. So we are given the sodium atom, meaning to say the sodium atom, the number of protons is equal to the number of electrons. And then we are given this ion, the sodium ion. So the sodium ion, sodium will lose 1 electron to F8. So we discussed this in the previous session, right? So, and then 23. And then let us say we are being required to give the number of electrons in the sodium ion. So for the sodium atom, we are having 11 electrons, right? Since the number of protons is equal to the number of electrons. But for the ion, we are not sure how many electrons are there. So we are going to use this charge. So the charge indicates that the positive sign indicates that we have more positive senders than negative senders. We have more protons than electrons, right? So the number here indicates the number of electrons being lost. So we have a 1 here, so we're going to subtract 1 electron to give us 10 electrons, right? So this is the total number of electrons within the sodium ion, the cation, right? The positively charged ion. And then we go on to do the same for calcium. So for calcium is 2 plus, and then here is 20, and then here is 40. So here we are simply going to say 20 for the number of atoms, but here we are having a plus 2, meaning to say we've lost 2 electrons, right? And then we subtract 2 for us to have 18. So I want you to take note of that the number of electrons is equal to the total number of electrons in a noble gas, right? And I'm sure this is very, very clear. 10, we go straight to the periodic table, neon number 10, and then 18, argon number 18. As simple as that. As simple as that. So the reason behind all the chemical reactions is to have a stable noble gas electronic configuration. So once you understand this, you can fully understand how to write the chemical formulas. So we're going straight to on how to write the chemical formulas. So we are now moving on to bonding. To bonding, right? So we are going to discuss how to write the chemical formulas after discussing bonding. For now, just understand, just appreciate how to write the ionic formulas. How to write the formula of the sodium ion, calcium ion using the periodic table. Simple application of the periodic table. If magnesium is in group 2, it will simply form 2 plus, right? And then if potassium is in group 1, it will form 1 plus. And then if aluminium is in group 3, it will form aluminium 3 plus. And then if oxygen is in group, it will form O2 minus, because it needs extra 2 electrons to have 8 in the outermost shell. And then if fluorine is in group 7, it will need extra 1 electron to have 8. And then if nitrogen is in group 5, it will need 3 electrons to have 3 minus. As simple as that. And then we said this one is for metals and non-metals, right? So you must understand that. You must understand this. Don't claim this, but you must have the understanding, so that whenever you're given that in element X and element Z, which is not there on the periodic table, you can simply figure out what is being required of you to do, right?